In the last section, we spent quite a while digging into the HTTP request, going through all the different lines of it and then looking at an example. We're going to do the same thing here. We're going to go to the other end of the spectrum and talk about HTTP responses. So we've had a client that's made a request of the server. It's sent all of its information, its request method, and so on. And now we have a server that has to respond to that based upon the method that was sent. So let's go ahead and go through the structure, and we'll start with the start line, the required portion of the HTTP response. Now we have a few fields here. First of all, we have the HTTP version. This was at the end of the start line for the HTTP request, but it's at the beginning of it for the start. Same concept as that one, but we're talking about the response in this case. After that, we have two things. We have the status code and the reason phrase, and these kind of go hand in hand. Now, remember, we have a client sending a request to a server. That server has to process that request, and hopefully that request was successful. Hopefully everything worked out well and it can process a request as it should, either by returning data, accepting some data, making a change, or so on. But there's a lot of ways that request can fail or that problems can arise. And the server needs a way to communicate those, and it's going to do that generally with a status code. So whether the response is good or bad, the status code and the reason phrase are going to relay that response back to the client. Now, again, status code and reason phrase are intertwined. Status code is actually a numeric 3-digit value that's a coded response. So like we think of HTTP 200 means okay, 404 means not found. Those things are the status codes. Now, the reason phrase is just a very short description of the status code. So you heard me say a minute ago, 200 okay. 200 is the status code. Okay is the reason phrase. That one means everything's all right. When I say 404 not found, 404 is the status code, not found is the reason phrase. So it's a very short 1, 2, 3 word description of the status code that goes along with it. It's actually embedded in clear text in the protocol. We don't see that with a lot of other protocols. A lot of times they'll just provide like a code or a number, and you have to go look up the other information yourself, or hope the Wireshark dissector puts it in there for you. But with HTTP, you get a reason phrase with the status code, which is pretty nice, and they're also very succinct, which is pretty cool too. Now, once again, same as with other HTTP traffic, same as with HTTP request, all these lines are going to be terminated with CRLF, or at least in this case, the end of the start line. All these three things will be in the same line, separated by spaces, and then you'll have a CRLF that terminates the entire start line where the response headers can then begin. So a couple examples. Here's one where the HTTP version is 1.1, and we have a 200 OK. So this is a positive response we would expect to see back when a response is accepted and data is delivered as expected. Here's an HTTP 302 found. We'll talk about what that means here in a little bit. But again, we have a status code, which is 302, and a reason phrase found, which is pretty straightforward. This one's often used to redirect people, but you kind of get the flow of this. Just by looking at the start line, you should be able to understand the nature of the HTTP response and what it means. Very similar to looking at the start line of an HTTP request. I do want to spend just another quick minute on response status codes, because these are important to know and learn. Now, there are a lot of them, and I don't expect you to memorize a lot of them. You just want to be able to be comfortable looking them up and understanding what they mean. But they are categorized, and I think an understanding of those categories is pretty important. So I mentioned they're all 3 digits, and really what you want to focus on is that first digit, because that first digit indicates the category. So for instance, any response code starting with a 1, so from 100 to 199 is going to be informational. Anything starting with a 2, 200 to 299, is going to be success. 3 is a redirection of some sort. 4 represents a client error, so an error spawning from the client side of the HTTP communication transaction. And 5 is a server error, so an error with the HTTP server. Now, from those categories, we have a lot of response codes that are more common than others. As a matter of fact, here are probably the 6 most common I think you'll generally see. So we'll go through those real quickly here. We'll talk about them a little bit more when we go into individual stimulus and response. The one we always want to see is 200 OK. OK means that our request was successful, and whether we're posting or retrieving data, whatever we wanted to do was okay, successful, everything was good. You notice it's within that 200 range. 200 okay, it's the lowest one, the first one in that 200 success range. After that, we have the dreaded 404 not found. Notice that that is a client error, so it's an error for the client because it means the client has requested something from the server that does not exist. The server will claim it's not its fault that it doesn't exist. It just doesn't exist. It's the client's fault for requesting something that doesn't exist. So 404 not found means we've requested a file or a page or a directory that is just non-existent on the server, and that it falls in that 400 range. 302 found. We talked about this as an example just a minute ago. It falls under a redirection. So this would be used in conjunction with an additional response header with a location. And it would say, this was found, but it's actually in a different location, and here it is. Then the browser would attempt to follow that redirection. So it falls in that 300 range. There are a few different types of redirections. We'll talk about a couple more of those a little bit later on with stimulus and response. 401 and 403 are somewhat related. So unauthorized and forbidden, it means you're attempting to access a resource on the server that you don't have permission to access. So that's seen as a client error because how dare you request to access that thing you don't have permission to access. So remember, on a web server, ultimately the web server data is just a series of directories that are being shared out on the server. There's things within those directories that we don't want all clients to be able to access, maybe sensitive data, certain subdirectories that are only useful for the server. We certainly don't want people to access things outside of that directory. So these 401 and 403 response codes are what you're going to see as a client when you attempt to access something you shouldn't be because you don't have access. You're either unauthorized or forbidden. And then we have 500, which is the first or lowest numbered in the 500 range, obviously, for server error. And it is quite broad. It can mean a lot of different things, and that's why you hate to see it so much, because it generally means the server screwed up, but you don't know how, and you can't usually do anything about it unless you control that server at least. So if you do control that server, it means you can check your logs, maybe see what was being requested, why the error was going on. You see this a lot in conjunction with scripted languages, things of that nature, so JavaScript, PHP, so on. Some type of error occurred, and it created an internal server error which did not allow the request to complete successfully. So these are just a few of the more common ones you'll see, but certainly not all inclusive. There are a lot more of them that you might run into, but these are probably the most common. Again, we'll dig into more of these with stimulus and response, but if you can memorize all these and what they do, or at least the categories, you're going to be a lot better off when it comes to being able to properly interpret HTTP response status codes. One more quick thing before we leave HTTP response codes, and I think this may be the most important thing I teach you in this entire course. Every now and then there comes along a service or a system that allows you to better remember something, and I think this is a great example of that. Of course, when all else fails, learn with cats, and we're going to do that with http.cat. So that is actually a website you can go to. So if you just type http.cat in your browser, you will get this website. And what you can do is hit / and just type in any response code. So let's say I don't know what HTTP response code 404 is. I can go to http.cat/404, and I'll get a cat that is a nice visual depiction of what that response code means. Let's try another one. Let's try 500. Oh, that's an internal server error. Well, we'll represent it this way with the cat literally inside the server. So when all else fails, and maybe you don't want to dig into the RFC, maybe you can explain it with cats. So make sure to check out HTTP status cats when the need arises. Now let's go through the HTTP response headers that can be included after the start line. And just like with request headers, there are a whole lot of these. They're going to vary wildly depending upon the server that's responding to the request. But I'm going to go through some of the ones that you'll see a little bit more often and more common. So I'll talk through these at a high level, and then we'll go through some of them in an example looking at an HTTP response and an actual packet capture. First, we're going to talk about the server field, and it's pretty straightforward in that it provides the HTTP server software that's acting on the server machine. So this could be, for example, just the Apache HTTP server, or even Microsoft IIS, Nginx, any number of different web server technologies. Now, you might ask, is this information spoofable? And absolutely, it certainly is. Matter of fact, most of the information in an HTTP header can be spoofed in one way or another for various purposes. But in a legitimate normal connection, generally the server is going to report its actual HTTP server technology in the response for the client to see. Next is location. And location isn't a field you're going to see all the time, but I did talk about it a little bit earlier when we talked about redirects, that whole 300 series of response codes. And redirects generally occur because a client has attempted to access a resource and that resource is not there anymore. So maybe it's moved temporarily, maybe it's moved permanently, but the server is aware that it's not there and actually has a new location for it. Now, that location might not be the exact location of that specific content. It might be a catch-all, or it might be a redirection to an error page. But nonetheless, the location field is included when a redirection status is provided, and it's basically just a URL. So, for instance, I might redirect someone to a validation page. Maybe they need to log in and they haven't. So when they go to access that sensitive content, I detect that they haven't been logged in, and I'll send them to a validation or a login page, which is essentially just another URL domain plus a URI in this case. So that's what the location field is doing. Not going to be present in every HTTP response, but it definitely will be generally in redirects that you'll see, and we'll see in some more examples in a little bit. Next, we have the content fields, and these are really serving the exact same purpose as the content fields we saw in the request. So we're talking about content encoding, type, language, etc. But in this case, we're describing the content of the response. In the request header, they describe the content of the request. Here, we're describing the content of the response. Most responses will generally have some form of content. That's a little bit different than a request, where oftentimes all the information you need is in the headers, so there's no message body to be found. Most of your responses will generally have a message body, so you'll see these content fields a lot more often. You'll see things described like content type. Here we're describing that we're delivering a content type of text HTML, so HTML, hypertext markup language, a web page in this case, or content encoding. In this case, we're describing that the content we're transmitting is encoded via gzip, right? So that is compressed for more efficient communication. And if the client wants to be able to interpret that data, it's going to have to be able to deflate that gzip information. Now, the cool thing here is obviously on the request side, we have the accept fields. So accept encoding, accept language, so on and so forth. The accept fields from the client side should generally match up to some degree with the response side, and that the client should note that it will accept whatever the HTTP server is responded with if you're going to have successful communication, right? So you'll see that those match up to some degree. Now, you generally won't be doing a lot of analysis and troubleshooting with this necessarily. Maybe on the security side you will, but it is important to know that there is an interplay of relationship between the accept and content fields from a request and a response. Now let's look at a couple of additional features for response headers that are actually unique specifically to the response and not something that you're going to see as well in the request. The first one of these are your cookie-related fields, and we've all heard and probably, or at least in concept, familiar with the idea of a cookie, right? It's something that it's a value that's set by the server generally on your client machine. And it has a variety of purposes. Basically, it's a way for the server to store some type of persistent data on your machine that it can reference later on. Now, this might include authentication information, so that's how they know that you're logged into a system and have permissions to access certain resources. A lot of folks use this for advertising, so they'll store a cookie that says you visited a certain site, and other entities can check it to learn that you visited that site, and then deliver targeted advertising based on that. Not really the greatest thing, makes you kind of feel icky a little bit, but that's one way that cookies work. So you'll see that actually in these response headers. That's where cookies are set, and you'll see that primarily through this set cookie mechanism, which creates that cookie, that piece of data. Now, here's an example of that. In this case, the format should be pretty clear. We have the name of a value. So in this case, like SWID is a name. We have the equal sign, and then we have the value associated with that name. In this case, we have a string of numbers here. And then that particular entity is terminated with a semicolon. So you see here across this, we have actually several different fields that are being set in this cookie. We have SWID, path, expires, and domain. So those are all pieces of information relevant to the cookie. The expire portion tells us when that cookie expires, a date time value. We have a domain value. In this case, that tells us the domain that this was created by. So a lot of things you might expect to see in a cookie are here, and you see that transmitted in the response back to the client via the set cookie field. The next thing I want to talk about is cache control. And when we think about caching, we think about efficiency and optimization. And you probably know that when you go to a website, every time you go to it, you're not downloading the entire contents of the website every time. That's why when you go to a website the second time, it's often faster than when you went the first time. And that's because of caching. So the mechanisms for caching are quite complex, and there's a lot of different processes that goes along with that. But for the most part, what you need to know is that caching is controlled in HTTP headers, and specifically HTTP response headers, where caching information is relayed back to the client, specifically citing directives on how the client can cache the results of the responses. So you can tell a client not to cache anything at all. You can provide date and time values of certain entities so that the client can compare against those, determining whether it needs to retrieve something anew, or it can rely on the cache, and so on. So we'll see a lot of different things related to that. So for instance, we might see the actual cache control field, and it might say no cache. It might say you can't cache it at all. We might see something like cache expires, which tells us that, yeah, you're probably going to cache this, but it expires at this particular point, and you need to be aware of that. You might even see the last modified date, and the last modified is used by the client to compare the current content versus the last time it was modified to determine if it even needs to bother retrieving the content again. So again, cache control, a bit of a complex subject. If you want to dig into that a little further, definitely check out the RFCs or some other tutorials on that. I'll provide a link to one, but we're not going to get into that too much here. But it is important to know that you will see these things. You will see cache control mechanisms in the HTTP response header quite often. Those are the main fields we're going to talk about for HTTP responses. So now let's actually look at some responses and see what those look like at the packet level. In this case, I've put a filter up here for HTTP response code equals 200. This will show me all of the HTTP packets that are responses and have an HTTP response code of 200, which we see over here in the info column. This is our start message in this case, or excuse me, our start line. In this case, we have the HTTP version, the response code, and the descriptive text that goes with that. In this case, it's simply OK. Now, if we go down here to the packet details, I've expanded HTTP. We see our start line right off the bat, similar to what we saw in a request, but different pieces of information. Our request had the request method in URI. This one actually has our status code and response phrase, which again are 200 OK. I'm going to close this out, and we'll look at the additional headers that were included in this case. First of all, we see content type, and this is specifying the content that is being sent back in the request. And this is a pretty important field. We probably didn't give it as much attention as we should have early on. But in this case, it's telling us the content MIME type is text CSS. Remember, most content will have some type of descriptive content type associated with it. So this one is text CSS. We might see HTML data. We might see image data. We might actually see binary data or some type of encoded raw data. A few different options here, but this is going to tell us what type of content we should expect. And if we actually go down and look down in the content section of this packet, the HTTP message body, we should expect to see CSS data. And if you look here, it says truncated, and then we do have indeed CSS data. We see divs and H1s and H2s and all those different things we expect to see from cascading style sheets, which are used to stylize HTML pages. So that's there, that's consistent, that's what we would expect. Now we have a few other interesting fields as well. We have last modified, which we talked about, which is related to caching. You see we have some other caching things here as well. We see cache expires down here, and it gives us a date. So again, caching, a little bit of a complex process with how clients go forth and determine whether they need to retrieve a page anew or whether they need to just rely on their cache. But those directives are in here as well. We see a server technology reported here. We see Microsoft IIS 6.0 is the web server that is being used here. So that information is helpful if we need to know what that server technology is. Going down, we have some content specifiers. We see that this content is actually gzip encoded. We see the length of it is 37,233 bytes. Of course, that means this is not all encapsulated within one packet. We're spread across a lot of packets. And the last one is the one that actually summarizes all that detail within Wireshark. So Beyond that, there are a few other fields that we didn't cover, and I'm actually going to intentionally not cover those here. A lot of them aren't super important for the analysis we'll be doing in this course. There is going to be a lab here in just a minute, though, where I'm going to actually ask you to look up some of this information on your own, so you get a little familiar with looking at HTTP RFCs, so you can find out what they're doing, answer a couple of quiz questions, and see if you can kind of challenge yourself to figure out what a couple of these more obscure ones mean on your own and exactly how these work. But nonetheless, this is an example of looking at an HTTP response packet. We've looked at the start line up here at the top. We looked at all of these different additional headers. We have our new line, and of course down at the bottom we have our HTTP message body, which is going to contain the actual data being transferred over the HTTP server. So that's we looked at your request. These are your responses. And with that said, you'll have a lab to do, and we'll also go ahead and start getting into stimulus and response and looking at the interplay between these requests and responses.